Oh, hello, Yerlin. Welcome back for the second part of today's lesson. Okay, let me hide this. So the next question is going to be about magnetism. What I would like you to do is answer this question on your mini whiteboard. So draw magnets and magnetic field lines around the bar magnet. I'd like you to recall the three magnetic elements, if you can. And let's imagine a situation where we have three different objects. One of them is magnetic, the other one is non-magnetic, the other one is a permanent magnet. How could you use a permanent magnet, not permanent object, permanent magnet, to identify each object? So take 3 minutes, please, and answer all of this on your mini whiteboard. Okay, hopefully you've completed all these questions as much as you could. Let's see. So around the bar magnet, you have magnetic field line starting from the North Pole going to the South Pole. Okay, a lot of them are going to be very close to the North Pole. Make sure you indicate arrows to show the movement of the magnetic field from north to south, always. Okay, it's very important to draw it this way. Easy marks to get, but also easy marks to lose. So this is exactly what it should look like. If you want to take notes like this in your book, feel free to do so. The three magnetic elements, the most common one is iron, Fe. You also have cobalt and nickel. So those are the three magnetic elements. For the other question, if you put a permanent magnet next to a non-magnetic object, nothing will happen. Okay, the object will not be attracted to it. If you put a magnetic object next to a permanent magnet, this object is going to be attracted to it no matter which pole is facing it. So if you put a south pole next to a magnetic object, the object will be attracted. If you put a north pole next to a magnetic object, the object will also be attracted. If you put two permanent magnets next to each other, if the north pole faces the south pole, they will attract each other. But unlike the magnetic object, if you reverse one of the magnet, and two north poles are facing each other or two south poles are facing each other, the permanent magnets are going to repel each other. And that's how you can differentiate between the three objects. One of them is not attracted at all. One of them is always attracted. One of them is either attracted or repelled. Okay, now again, can you take 5 minutes? So pause the video for 5 minutes and answer question 4. All right, welcome back. Please get your green pen and go through question 4 together. So, figure 8 shows a permanent magnet and two magnetic compasses. The pole of the magnet are labeled X and Y, and we can see that the magnet is attracted to pole X in that direction. So remember, the magnet goes from north to south. So here the compass needle is pointing toward the south, so X is south. Therefore, Y has to be north. And to show that the magnetic field is going away from the North Pole, the arrow is going to go from left to right, as drawn here. Okay, so make sure you have all this correct answer in green on your test. Then, which of the following are magnetic material? So not aluminium, not copper, iron, yes, lead, no, nickel, yes, tin, no. So you had to tick 2 boxes, and remember you can add somewhere that cobalt is the third one. Okay, FeNiCO. Next, 4.4. Which of the following describes the force between a magnetic material and a magnet? So if it's magnetic, it's always attractive. Okay. The force can be either attractive or repulsive between two permanent magnets. So remember, north and south attract, north and north repel, south and south repel. The shop assistant removed the security tag and dropped the tag into a collecting bin. As it falls, the tag accelerates at 9.8 meters per second square, so that's the acceleration in the right unit, and the mass of the tag is 0.03 kilogram. So remember, in physics, the unit for mass is kilogram, so we are happy with 0.03 kilogram. We don't have to convert it. Calculate the resultant force acting on the tag. So the mass is 0.03, the acceleration is 9.8. So to calculate the resultant force, we're going to do 0.03 times 9.8, which is 0.294 Newton. And that is the answer that would give you the 2 marks. Again, show your work always, okay, just in case something goes wrong with your calculator. If you have 0.03 times 9.8 somewhere, that gives you a mark. Okay, next bit, stopping distance. Again, on your mini whiteboard, can you tell me what is meant by thinking distance and what factors could affect it, and what is meant by braking distance and what factors could affect it? Please pause the video for 3 minutes. All right, welcome back. So the stopping distance is the sum of the thinking distance and the braking distance. The thinking distance is the distance traveled while you are processing the idea that you need to brake. Okay, so is the time it takes for the message that you're seeing some danger on the road to be sent to your brain, and for the brain to send a message to your muscle to start braking. The factors that could affect thinking distance could be being tired, or age, or being under the influence, or taking medicines, or drugs, or caffeine, which is going to shorten the thinking distance. The braking distance is the distance traveled by the car or by the vehicle while you're pressing the brakes. So the factors that could affect the braking distance could be the quality of the tires, the quality of the brake, the quality of the road, the conditions. Is it wet? Is it icy? Is it dry? Is it a smooth road or is it a bit of a dirty road, etc.? Those are all going to affect the braking distance. Okay, so now please take 5 minutes to answer question 5. Please pause the video. Okay, welcome back. Please get your green pen. Let's go through question 5 together. So the stopping distance of a car depends on the thinking distance and the braking distance. Which of the following affects the thinking distance? So the conditions of the brake, remember, are going to affect the braking distance. Icy road conditions are also going to affect the braking distance, but not the thinking distance. The reaction time of the driver is going to affect the thinking distance. Okay. So the first two affect the braking distance and going to make it slightly longer. The reaction time is going to affect the thinking distance. The car manufacturer tested 3 different types of tire, which were fitted to 3 identical cars. This is the method used. Drive the car along a road. Apply the brakes until the car stops. Measure the distance traveled while braking. Repeat steps 1, 2, 3 for each car when the road is dry and when the road is wet. The brakes were applied with the same force for each test. Give one other variable that should have been kept the same for each test. The car should be going at the same speed. Okay, so the initial speed should be kept the same, otherwise it wouldn't be a fair test. If you're traveling a lot faster, it's going to take way longer for the car to stop, so it wouldn't be fair. So the same speed would be perfect. You could also have the same portion of the road, but ideally the initial speed would give you the mark. 5.3, this is the result we get. The manufacturer wants to put the safest tires on a new car. Evaluate the safety of each type of tire. So the safe tire are the one that's going to decrease the braking distance. Okay, you don't want to travel a lot while braking, so you want the braking distance to be the smallest possible. So already you can say that type B is the tire B is the less safe because you're traveling in 42 to 43 meters while braking on either dry or wet road. Okay, then you're going to compare A and C. So to get the full mark, you're going to have to say that with tire A, the braking distance is 30 meters on dry road and 31 meters on wet road. So tire A has the shortest braking distance on wet road, okay? Because if you look at tire C, it travels 40 meters on wet road, but tire C, has the safest is the safest on dry road because the braking distance is only 29 meters. Okay, so then you get marked for judgment. So you need to say somewhere that the shorter the braking distance, the safer the tire. You can say that tire A is a meter longer on dry road, but is 9 meters shorter on wet road than tire C. So it's probably better. Tire A has the shortest combined or average braking distance, depending on the road. So overall, you could say that tire A is the safest. You can then say also that tire C is the safest on dry road. And you can say that tire B is the least safe of all on any type of road. Okay, so take a minute to write down a 6-mark answer for this. Please pause the video while the students are writing down a good answer to this question. Okay, next question. When the brakes are applied, a force does work to stop the car. Use the physics equations sheet to answer question 5.4 and 5.5. Write down the equation that links distance, force, and work done. So if you look at the equation, you will find that the work done equals force times distance. The symbol for work done is capital W and is measured in joules. Force, the symbol is capital F, measured in Newton. And the distance has graded the symbol S and is measured in meters. The braking force acting on a car is 6,000 newtons, so that's the force. The work done to stop the car is 300,000 joules. So that's the energy or the work done. Calculate the braking distance of the car. So we're looking for S. So let's start. F formula, work done equals force times distance. Let's insert value. The work done is 300,000 joules. It's the correct unit. Equal 6,000 Newton. That's the correct unit for force. Times S. Fine tune. We're going to make S the subject of the equation by dividing both sides by 6,000. Not by 6. I made a mistake here. It should say 300,000 divided by 6,000. And the answer is therefore 50 meters. Okay, again, show all your work. It is worth it. You don't want to lose mark by making a wrong calculation in a calculator. So make sure you show all your work as clearly as possible. And make sure you don't write down 6, but 6,000. Explain how the force applied by the brakes affects the braking distance of the car. So the greater the force, the shorter the braking distance. That's 1 mark. Because the deceleration will be greater, or because the work done to stop the car will be the same. Okay, but I think the best answer is the first one, because deceleration will be greater. So if you're losing speed faster, you will stop faster. Okay, I'm gonna make a new video for this one.